Hi everyone. So for this is review for exam number 8. Okay, so I am going to do the odd problems, then I'm going to assign you the even so you can study for the test. And I am not going to take long. I'm going to go faster with these problems because I've done this before in the previous videos. Okay, so for example, factor completely. Always look for a GCF. In this case, 10 goes into 30, so we can factor out 10. But also notice they have x in common, so 10x is the GCF. So then instead of 30, that becomes 3x, and instead of negative 10, x becomes minus 1. And this is factor completely. Okay. Number 3, there's a negative lead, which I'm going to factor out first. So factor the negative lead, then this becomes positive x squared. This changes to negative 6x. This changes to negative 16. From there, find the multiples of negative 16 that when you add those multiples, they add to our b value of negative 6. So then the multiples that do this are, which ones? 2 times 8, right? So 2 times 8, but then we need a negative 6 when we add them, so the a should be minus. So then this is simple factoring again because a is 1. So x minus 8 times x plus 2, and that's the answer to that problem. Number 5, this is a difference of squares. So then this factors as x minus 10 times x plus 10. And then number 11, it says a rectangle has an area of x squared minus 19x minus 66. One side has a length of x plus 3. What is the rectangle's perimeter? So they give us one side. So far we know that x plus 3 is one of the linear factors, right? So that we are given. So let's find the other. So then I need to find multiples of a times c, a being 1 and c being negative 66. Okay, so find multiples of negative 66 that when you add those multiples, they add to negative 19. And those multiples are 3 times 22. But notice when we add them, we need them to add to negative 19, which means that 22 has to be negative. And when we multiply them, we get negative 66. So we have the x plus 3 already, so the other is x minus 3. So now this is a rectangle, right? So it's a rectangle, and we need to find a perimeter. So sketching the rectangle, let's say this is x plus 3, and this is x plus 3, and this is x minus 3, and x minus 3. So add all the x's, 1, 2, 3, 4. So the perimeter is equal to 4x, and then we have negative 3 plus 3, the 0, 3 and 3, 0. So this is the perimeter, right? So the perimeter is 4x. All right, so that's number 11. Let's go to the next page and do number 13. So this is review. So it's going to find the slope-intercept form of the equation containing the points 3, negative 7, and 4, 1. So this is x1, y1, x2, and y2. Finding the slope, which is delta y over delta x, or changing y over changing x. You take the y2 value, which is 1, subtract the y1 value, which is a negative 7, and again, negative from negative, this becomes plus. And x2 value is 4, minus x1 is 3. So then this is 1 plus 7, which is 8, and 4 minus 3 is 1, which means the slope is 8. Okay, so once we find the slope, next what we can do is we can either use point slope form and then convert to slope intercept form. So point slope form is, let's see, y equals m times x minus x1 plus y1. Okay, this is one version. So then y equals m is 8, x minus x1, x1 is 3, and then plus y1, y1 is a negative 7, so this means instead of plus becomes minus. So then distribute. So I'm going to come over here. So y equals 8x, okay, distributing, and 8 times negative 3, that's negative 24, minus 7. So then the equation in slope-intercept form is y equals 8x minus 31. And that's the equation of that line that passes through those two given points. Okay, number 15, state the domain and in interval notation of the graph. So domain, you read from left to right. So notice it goes, this is the farthest it goes to the left, and this is where x is 0, and the farthest it goes to the right is here, where x is 4. So then the domain in interval notation, and notice those values are included. So I'm going to use a bracket at 0 and then also a bracket at 4. So there is the domain. The range has a bottom and has a top. So the lowest is negative 4, the highest is 4. So I'm going to do this one real quick. So the range is from negative 4 to positive 4. Okay, so there we have the domain and the range. Number 12, it says let f of x equals negative 4x plus 3. Find the range for the domain, this domain. So then all I need to do is, let's do f of negative 3, that's the first value, and that equals negative 4 times negative 3 plus 3. Well, this is 12, right? 4 times 3 is 12, and it becomes positive 12 plus 3, that's 15. So f of negative 3 gives us 15. And then let's do f of negative 1/2. So f of negative 1/2 means we have negative 4 times negative 1/2, and then add 3 more. Negative times negative is positive. Half of 4 is 2, and 2 plus 3 is 5. So f of negative 1/2 gives us a 5. So when the input is negative 1/2, the output is 5. And then let's do last 5 over 6. So f of 5 over 6 is equal to, so then we're looking at this formula here, so 4 times 5 over 6, and then plus 3. And you can do this with a calculator for the sake of time. So I enter this in the calculator, and then when I press enter, it gives me negative 1/3. So this is negative 1/3. Again, I am not going to penalize you if you use a calculator for this. It's okay if you do for this test, okay? So then the range for this problem, least to greatest, so this is the smallest of the y values in the range, so negative 1/3, and then 5, and then last 15. So this is the range for the given domain, okay? All right, so let's see, let's go to number 19. Number 19, suppose the equation y equals x plus 7 has changed to y equals x minus 2. The absolute value of x plus 7 and the absolute value of y minus 2. Describe the changes made from the first equation to the second equation. So we know this is coming from negative 7 for x, and since plus means go left and minus means right, so we go from negative 7, this goes right 2 from 0. So will you agree with me that this line, this graph, this v-shaped graph, which is the absolute value function, gets translated? Okay, so the graph, I would say the graph gets or is translated. This will be 9 units. 9 units to the right. Okay, and that's all for number 19. Number 21. Graph after converting from vertex to vertex form. So then what I need to do is I need to find, see if there's a GCF. If there's no GCF, then what I can do next is I can factor out the negative lead. So then y equals negative, let's see, actually we can factor negative 2 as a GCF on the first two terms. So then this becomes x squared, and this switches to 4x. And then we have minus 5 outside. Okay, so we're going to do this by grouping, and I know we've done this like 2 or 3 weeks ago. So then take this value, divide that by 2. So then y equals negative 2 times x, and this becomes plus 2. Take the square, minus 5, and then determine what we need to do outside, undo outside. So I'm going to take the 2, I'm going to take the square of 2, and that gives me 4. But keep in mind, we factor out the value of a. So then multiply, which means we multiply that 4 by negative 2, which becomes negative 8. So this we need to undo outside. So then this is plus 8 instead of minus, add 8. So then the equation in vertex form is y equals negative 2 times x plus 2 squared plus 3, which means the vertex point is located at, let's see, so this will be negative 2, positive 3. So go left 1, 2, and then up 1, 2, 3. Plot a point here. Okay, the axis of symmetry, let's see. Okay, I hope you remember this. The y-intercept is a 0, negative 5. So I'm going to plot that point. 1, 2, 3, 4, 5. And we get this from the center form equation. Okay, so from there, if you sketch the line of symmetry, This is the line of symmetry, which is where x is -2. Then if we have a point on this side of the line of symmetry, we should have another one the same distance on the opposite side. Okay, so those 3 points should be enough. But if you want to get 2 more points, that's fine. So using the table, mentally, if I go left 1, I should go down 2, right? Because it's 1 squared, but then multiply by -2. 1, 2, put a point here. But if I have a point on this side of the line, I should have another one on this side. Then with those 5 points, connect them. And this is the parabola that represents that quadratic function. Okay? All right. Thank you for watching. Bye-bye.